Welcome back, sixth graders. Today we're taking a look at the length of line segments on the coordinate plane. This is lesson 9.2 in your Math and Focus textbook. If you take a look, here it says that we're going to plot each pair of points on the coordinate plane below. Connect the points to form a line segment and find its length. So I'm noticing that there are multiple parts here. So I kind of want to be a close and critical reader when it comes to a big long set of directions like this. It says plot each pair of points. So that's the first thing it told me to do. So step one, okay? Or maybe part A, maybe that's good, okay? Part B, it says connect the points to form a line segment. So connect the points, that's part B. Next it says find its length. So part C, we need to find the length of the line segment. Let's go ahead and take a look at the coordinate plane that we've been given. If you notice, this coordinate plane is not complete. I started out your x-axis, which is this horizontal number line, and your y-axis is kind of being hinted at right here. This vertical number line we just need to complete. A number of my students like to number off their coordinate plane and show the axes with different numbers or number values. We can do that, but I do caution you, if you decide to do that, you do want to make sure that you are numbering right on the lines. So I'll start here at the origin, also known as 0, 0, and I'm going to move to the right on my x-axis first. And moving to the right will get me to positive numbers, 1, 2, 3, 4, etc. And I want you to notice that I'm actually putting those numbers right on the lines. Well, what would happen if I moved from the 0, 0 point, or the origin, behind 0? Well, that's like a -1 or a -2. It's the same as taking away. It's really the same numbers that I'm seeing on the right hand side appear on the left, but with negatives. Next, I want to consider my y-axis, this vertical number line. So moving up from the origin, I would land at 1 or 2 or 3. Again, the positive integers. And moving below 0, 0, I would land at the negative integers. So if you want to count yours off, again, my caution is to students who are doing this themselves, make sure you number right on the line, not inside the box, so that we can really keep track of our units when we're counting. All right, we're ready for number 1. If you notice, I kind of color-coded this today. I showed you that the x-axis is going to be the first number, or in blue, we're going to move from left to right. Next, I have the y-axis. I'll color code the second coordinate in red, and I'll show you that that number is going to make us move up or down. So just color coding to maybe help you see how to move on the coordinate plane. All right, let's go ahead and find point A to start, because it did say plot each pair of points. So point A is located at +6, +2. Well, starting here at the origin, +6 says move to the right 6. So here I am at +6. Then it says +2. So am I moving up or down? Up to the positives, we'll put a point and we'll call it point A. You can check that off. We found point A. Next I'm looking for point B. So I could color code this again if I choose to. I could remember that the first coordinate tells me to move left or right. The second coordinate is going to tell me to move up or down on the y-axis. Let's go ahead and try to locate +6 and -3. Starting at the origin, left or right first for +6. +6 is to the right. Next I'm looking for -3 from there. So that -3 means up or down on the y-axis. Well, negatives are down, 1, 2, 3. This is the point we're looking for. This is point B. We've done what they asked for part A. The first part of the problem says plot the points. Then it says part B, connect the points, form a line segment. So I'm going to just go ahead and connect the dots here. And now I've formed a line segment. The line segment's name is AB. That's what this line segment over the top of the two letters means. That stands for line segment AB. That's how I read this. We want to make sure we take care of the third part of the problem, or the directions, which says find the length of the line segment. So I'm going to come back over here to my line segment AB, and I could do that a couple ways. I could consider counting the hops. I could say how many hops is it from one side to the other. So 1, 2, 3, 4, 5. Looks like I'm getting 5 units. Someone else might say, oh, well, I could actually just look at the y value. Here, this y value is at 2. and the other y value is way down here at -3. So thinking about absolute value, A is 2 away from the x-axis, while B is 3 away from the x-axis, and 3 and 2 gets me the same 5 units. Let's go ahead and answer this. Line segment AB is actually 5 units in length. Now they don't tell us necessarily if we're measuring in feet, inches, miles, kilometers. We don't really know. So for that reason, we'll use a generic label of units. Let's take a look at number 2. We're going to follow the same 3 directions. We're going to plot points, connect the points to make a line segment, and next find the length of the line segment. And I gave you a hint here with this notation that we're going to want to talk about line segment CD and its length when we're done. Let's go ahead and see if we can find -4, 0. And again, I could color code these coordinates for you. The first coordinate will get the blue for the x-axis. The next coordinate could get the red for my y-axis. And I just chose those colors really at random, but I'm going to kind of stick with that same pattern to help you see that the first number moves left or right. The second coordinate gives me the up or down, the vertical number. Let's go ahead and find -4, 0. We'll start here at the, what's this place called? Origin. And I'm going to move -4, which means left or right? Left, 4. We'll find my -4 location. But then it says 0. It says 0 up or down. If you can't move up or down, I guess that means we get to stay here. This point is known as point C. I'll cross it off just to keep track of where I am with you right now, and I'm looking for point D, which is located at 3, 0. So starting here again at this middle location where the x and the y axes intersect. Well, this is also known as the origin. And I want to move 3. Which way for +3? First to the right. The next value says 0. So that y value tells me I cannot move up or down. I'm going to stay right here and plot point D. Well, we plotted the pair of points. Next it says form a line segment. So I'm actually going to trace right along this x-axis. With your pencil, you might have to be a little bit darker with your writing so that it shows up, or you might want to use a color to do that. The third direction says consider the length. So I could really count the hops from point C to point D. I could go 1, 2, 3, 4, 5, 6, 7 hops or jumps. So my answer is going to be 7. Someone else might say, well, I noticed when you look at these two numbers, the -4 and the 3 are different. The zeros match. So if -4 and 3 are different, I could think about the distance between them. Well, that's like saying the absolute value of -4 plus the absolute value of +3. And if you remember, absolute value means how far away it is from 0. That's like saying 4 units plus 3 units. Will I still get the same great answer of 7 units? Sure will. So let me go ahead and record that 7 units as a final answer. Some of you will appreciate, oops, I kind of missed my answer there. Try that again. Some of you will appreciate that shortcut of thinking of absolute value, adding the 4 and the 3 units together to get 7. Let's go ahead and try 1 or 2 more together. So for number 3, they tell me to plot the pair of points. So, oh no, I lost my coordinate plane, didn't I? I better go back a step and see if we can redo that. Really, all I want to erase is this piece of it, so I have some room to work. All right, let's try that again. So next I'm looking for point E and point F. I'm going to plot the pairs. So point E is located at -5, 3. I hope you remember the first number means right or left. Next number means up or down. And I did get rid of my color coding, but we could go back to that if it's helpful. The first value always means move on the x-axis. The second value always tells me to move on the y-axis. So kind of color coding with our axes the way I drew them in for you today. All right, -5, 3. I need to start at the center location in this situation, and it's called the origin. And I'm going to move -5 to the, hopefully you said left, because my negatives are over here. Next is the elevator going up or down. You might say we're going to the 3rd floor, we're heading up. 1, 2, 3, this is the intersection. I plot a point right where those lines intersect, and I'm going to call this point E. Crossing it off to keep track of where I am. Next I'm looking for point F, so moving a little quicker with you. I'll start here at the center, also known as the origin, and I'm going to move 1 to the, hopefully you said right. And next it says +3, so I'm moving which direction? Up 3, going to the 3rd floor, just like the other point did. And that was part A. It says, go ahead and plot your points. Part B says, make it a line segment. Well, that's a little wavy, sorry about that, but I think it'll still work. And the third rule says, go ahead and tell me the length of line segment EF. So I'm going to give you the beginning point, the end point, E and F, and I'm going to show you this little line segment symbol right above them. Well, let's go ahead and figure that out. We could go ahead and count our jumps. Or we could go ahead and talk about the distance and the numbers that don't match. Well, the 3's match, so I'll kind of ignore those. And the 1 and the -5 do not. Oh, well, one is a negative number, the other one is a positive. And when they land on different sides of an axis, in this case the y-axis, I need to add those values together, thinking about absolute value or the distance of them. Well, let's just count our jumps again. I'm getting 6 working that way. Or the absolute value of -5 is 5, and the absolute value of 1 is 1. If I add those together, we should get an awesome answer of 6 units. We could check it either way. All right. We'll take a look at one more, and then I'm going to see if you can handle number 5 and 6 on your own. So number 4. Oops, I don't want to erase everything again. Let's just change colors. Let's color code. My first values tell me to move left or right. My next values tell me to move up or down. Let's go ahead and give it a try. Point G is located at -2, +3. First I move left or right. So which way for negatives? Left 2. Which way for +3? Up 3. We're kind of reusing part of this line segment, and that's okay. That could happen. We'll call that point G. Next we're looking for point H. So I'm looking for -2, -3. Starting here at the origin, I need to move -2, which means to the left, and -3, which means up or down? Well, down 3 floors. If you remember, your core teacher did a nice job of showing you a picture of an elevator in Europe where they actually use negative numbers for floors below ground level. Kind of cool. All right. The next thing we need to do after we plot our points is connect them. Make a line segment. And the last direction said find the length. So again, I could count my hops here. I'm starting at one point and moving all the way to the other. And if you were counting with me, that'd be 1, 2, 3, 4, 5, 6. Looks like that might be 6 units as well. So how do we show that? Well, I had a starting point of G, I had an ending point of H, and it's a line segment. So I totaled up the number of hops, I came up with 6 units. Is there another way to get that same great answer? Take a look. Are there 2 of these numbers that match? Yep, the -2, we can ignore those, but 2 of these numbers are not alike. That's where I'm going to find my distance. I'm going to think about the absolute value of 3. Oh, it's 3 units away from 0, isn't it? Right here, that 3 is 3 units away, 3 units above the x-axis. And then that -3 means it's 3 units below the x-axis. Oh, 3 and 3 makes 6. It makes sense. I'm not going to show you numbers 5 and number 6. I trust that you'll be able to do that. The only thing I will point out is number 5 is tricky because it has those zeros in it. So remember, the first number we've been using, probably need to go back and figure out my color code. First number we're using is the x-axis. So will I get to move left or right when it says 0? No, you will not. You can't move left or right. So the next number is going to tell you how much to move up or down. So will I be able to move up or down? Absolutely. Let's go ahead and move ahead in our assignment. So if you need to pause my video so you can work on 5 and 6 that you were missing, that's awesome and great. I'm going to take a look at number 7 when you're ready. It says find the coordinates. Number 7. Rectangle ABCD is plotted on a coordinate plane. Well, let's stop a minute. Whenever I'm reading and I run into something important, I like to kind of highlight it or underline it. It's a rectangle and it has a special name. Remember, those names tell me something important. Those coordinates need to be connected in order. All right. So this rectangle ABCD is plotted on a coordinate plane. The coordinates of point A are 1, -1. Well, that's kind of important. Right here, point A goes with 1, -1. And the coordinates of point D are 1, 2. Each unit on the coordinate plane represents 1 centimeter. Oh, this is interesting. They actually give us the unit that we're measuring in. We won't use generic units. We'll actually talk about centimeters. And then it says, and the perimeter of rectangle ABCD is 18 centimeters. Well, that's kind of important, and all this underlining is kind of causing me some trouble because I'm using all the same color. Let's go ahead and underline perimeter and 18 centimeters. That sounds important to me. Find the coordinates of points B and C given these conditions. Oh, there are some unknown coordinates. So I'm going to have to find B and C. And sometimes I like to circle the question, so they're kind of asking me to find B and C. That's kind of the question in this situation. Well, let's go ahead and see if we can plot the few things we know. So we were given point A. They said point A is located at 1, -1. Well, before I should even try that, I better get myself a y-axis. I see I didn't draw a y-axis for you. And do pretend that that x-axis is a little more aligned with that actual line. I wish it were. So we'll pretend that that x-axis is actually sitting there on that line. And if you decide to number this off, you may. That may be helpful to some of you. And if you decide that you can just count units without that, that's acceptable also. So I'm just going to try counting units with you this time. Again, numbering off, if you decide to do that, you got to make sure you get those numbers right on the lines. That's kind of a -2. That looks crazy, isn't it? All right. Let's go ahead and try to find 1, -1. We'll call that point A in a second. So 1, -1 is the first thing I'm going to tackle. We'll start here at the origin, and we'll pretend that these are a better intersection than I see. And I'm going to move 1 which way? To the right. And next I get to move up or down for -1. Hopefully you say down. Let's go ahead and plot this point. This is point A. Check. Next I'm looking for point D. They skipped over B and C, I noticed. They gave me point D. And they say D is located at 1 and 2. So I'm going to start here at the origin, the center of my intersection of the x and y axes. And I'm going to move 1 to the right. And next I'm going to move 2 up. This is point D, they said. Check. Well, the only other thing I know is that I have some missing coordinates. I'm trying to turn this into a rectangle, which I want to do, but 2 points don't make a rectangle, do they? Well, is there anything I can connect at this point to start the rectangle? I'd connect A to B if I could. There's no B up here. I'd connect B to C if I could, but there's no C up here. I'd connect C to D if I could, but there's no C up here. So, do you remember what to do with that last point and the first point we were given? Oh, that's right, those get connected. That's what closes it in the figure. So I at least know, oops, that I'm really off the line. I do know that too, that A and D get connected. That's one edge or side of my rectangle. Let's go ahead and read on. Part A. Points B and C are to the right of points A and D. Points B and C are to the right. Well, here it's important to me that we think about this direction being right and this direction being left. So I know B and C could be anywhere over here, and I really want to make a rectangle. So what am I missing? Can I just guess where they go? B and C and C and B and... Not really. There's a piece that we highlighted in blue a little bit ago. We said it's the perimeter. The perimeter is 18 centimeters. What does that mean, perimeter? This is important. Perimeter. Some people will describe it as the distance around a closed figure, right? So the distance around. Some people have learned that's called the sum of all sides. So we also could just remember that we're going to add up all the sides. That's another way of thinking of it. So I want a perimeter of 18. That's not super helpful at this moment unless I consider how long this edge is already. Line segment AD is 1, 2, 3 units long. Oh, if AD is 3 units long, 3 units. And remember they're measuring in centimeters. I could have written cms there. Well, if that's true on this side, what would be true on the opposite side of my rectangle wherever it happens? Oh, it would also have to be 3 units long. Well, 3 units plus 3 units uses up only 6 units of the perimeter. And I have how many to work with? 18 of them. So 18, take away the 6 units from the edge, leaves me with 12 units to work with for the top and the bottom. Well, I want my rectangle to have equivalent sides on the top and bottom. I want them to be congruent. So how could I split this 12 into 2 equal groups? Oh, isn't it the same as 12 divided by 2? So I'm thinking here I'm going to take my 12 units and split them into 2 equal sides. Well, 12 divided by 2, I could think of a fact, 2 times something gets me 12. I'm going to get 6 units for both the upper and the lower edges. So let's go ahead and sketch this in. If I start here at maybe D, and I want to make sure that I move to the right, it said, to the right, I'm going to find point B and C. Well, I need this to be 6 units long. We just discovered that down here. I have to think about that 6 units when I count out. So I'm going to start drawing and count when I hit those intersections. 1, 2, 3, 4, 5, and 6. I know a point belongs here. I could do the same thing with this edge that starts at A. I could count over 1, 2, 3, 4, 5, 6, and put a point. And if I were to close this in, would this make a rectangle? It absolutely would. The thing that we're missing here is the values and also the point names. So let's go back to the name of our rectangle. A is connected to B, so A connects to point B. B connects to C, so B to C. And C connects to D. C and D will also have a line segment. And remember, we closed it in. This looks great. They say find points B and C when they're to the right of A and D. So point B and point C. Let's talk about their coordinate pair. Point B is located way over here to the right, isn't it? So let's count. How far did we have to move on the x-axis? 1, 2, 3, 4, 5, 6, 7 units to the right. And then did we go up or down? We went down to get to point B. We went down 1 unit. So I could say 7 to the right and -1. We're looking for the coordinates of point C. And to do that, I'm going to have to consider how far I moved to the right this time. 1, 2, 3, 4, 5, 6, 7 units to the right again. But instead of going down, I moved up. How many hops or how many units? 2. So we still moved 7 units to the right, but this time 2 up. This is what they're looking for, to give the coordinates of points B and C in this situation. Well, we get to try this again, and this is one of my least favorite things about Math in Focus, is that they're asking us to reuse the same coordinate plane. But we're going to try it. So let's go ahead and look at this next section, which says points B and C are going to be to the left of AD. That means I'm not going to use these points this time. I'm just going to think about them from earlier and say, oh, okay, that was great for part A. Part B, I have new rules. I want B and C to be to the left. Well, left is over here, so I need to move, how many units did we say that top edge had to be? 1, 2, 3, 4, 5, 6 units long. So let's just move in the other direction. 1, 2, 3, 4, 5, 6. I know a point belongs here. And I can do the same thing at the bottom. Moving behind A 6 units. 1, 2, 3, 4, 5, 6 units. I can also place a point here. If I were to close this in, would it work? Let's try it out. I'll use a different color if we can. Maybe this light blue will show up for you. I can connect D to this point and A to this point and connect this opposite edge, which again I'm having trouble staying on the line. Does that make a rectangle? Reusing this edge AD? It looks like it. Now remember this rectangle's name. A connects to B, B connects to C, and C connects to D. So in geometry, when we name a figure, we try to name it with its vertices in order. That's what you're seeing here. Great. Now we just need to answer what are the coordinates of B and what were the coordinates of point C in this new situation. So point B is way over here. It's behind the origin. So I have to move backwards, -1, -2, -3, -4, -5. And then drop down 1. It looks like I'm moving -5 to the left, and then dropping down 1 means go to -1. How about point C? Well, I still start at the origin and I still move left. 1, 2, 3, 4, 5 hops to -5. And next I move up. How far? 2 units. So -5 to the left, +2 up. We found the missing points and their values, their coordinate pair. Good. Let's go ahead and clear this. Let's see what's happening in our next page. Something very similar, but this time it says we're not working with a rectangle, they're giving me a square. So I'm picturing a square in my mind. picturing I should probably be on a pen when I start writing for you. A square, and it has a special name, EFHG. That's interesting, kind of in a funny order, EFHG. All right, it's plotted on a coordinate plane. The coordinates of point E are given. The coordinates of point F are given. Find the coordinates of points G and H given these conditions. So notice G and H are the question this time. G and H, where are you located? And I can start by plotting points, right? We know how to do that quite well. I just need to fix up my coordinate plane so that we have a y-axis, something my computer doesn't like to do. Kind of looks like we've got a double x-axis here by accident, but we're going to make it work. We'll just show that that goes on forever. And let's go ahead and find point E first. First I want to move -2, then I want to move 1. -2 on the x-axis, -1 on the y-axis. Then I'm going to look for this point, +2 on the x-axis and +1 on the y-axis. All right, starting here at the origin, I want to move -2 to the left. 1, 2. Next I want to move 1, heading which direction? Up. This is the first point we're looking for. This is point E. I'll just label it E. All set. Next we could plot point F. We know how to plot points on the coordinate plane. I can start here at the origin and move +2. Does that mean right or left? Right for my positives. And +1 means up or down. Hopefully you said up for my positives on the y-axis or with the y value. I'll just label that point F. And we're ready to look at the conditions. That means the rules. What rules will apply? So I notice that this E and F, I hope that they're connected. I'm not sure if they are, so I want to go look at this polygon's name. This square is called EF. Do you see how E and F are next to each other in the name? They will be connected. That's good. We have an edge of our square. Oh, I know something about squares. This doesn't look like one. In fact, this looks like just a straight line. It looks like a line segment, I should say. And in this case, that's not enough of a square. Squares have how many sides? 4 sides. And squares have what kind of sides? Maybe you'd say equivalent or congruent, right? All the sides are equivalent or congruent. So if I know the length of this side, I probably could figure out the length of all the sides. In fact, let's go ahead and count how many units we see here. This line segment is 1, 2, 3, 4 units long. That took 4 hops to get there, didn't it? So, oops, dropped my pen. Let's go ahead and show that that's 4 units on every side of my square. That will be helpful in a minute when I go to find some missing vertices or some missing points on the coordinate plane. So part A, it says find points G and H if they're above points E and F. They're going to be above. This word above means move up, right? Up above this line segment. So if this was 4 units long, I need to make sure every edge is 4 units long. So I could start here and count up 4. 1, 2, 3, 4. I could plot a point. I could do the same thing on the other side. Counting up 4 units would also land me on the same altitude, if you will, or the same y value. If I were to close this in, E is connected to F. That's what it says in the name. F goes to the next point in the square, and its name must be H. And next it says H is connected to G, so I'll go back and connect here to point G, and to close this figure in, I'll go from G to E, the beginning point, or vertice. If you take a look, do we have a square? We absolutely do. Now the real question is, where are these points located? So I need to tell you, oops, I just wrote on my video recording, my toolbar here. I need to tell you the coordinate pair for G and the coordinate pair for H. So that's kind of going off my screen here, but I did show you a spot where we could record those answers. So point G, well, starting at the origin, do we move left or right? We moved left. So is that a positive or a -2? That's a -2. And next I had to move up, didn't I? Are the numbers above the x-axis positive or negative? They're positive. So I took 1, 2, 3, 4, 5 hops forward or up, and that's a +5. So -2 to the left, +5 up. Next, point H. Well, I didn't move to the left of the axis for that one. I moved to the right. I moved to the right 2. So what kind of 2 would that be? That'd be a positive 2. And next, instead of moving down, I moved up. So I'm looking at moving up how many units? 1, 2, 3, 4, 5 units. Positive 2, positive 5. This is the coordinate pair they're looking for point G, and the coordinate pair they're looking for point H. But then, of course, they want us to reuse our coordinate plane. So we'll take a look at part B and see what we can do. We're still dealing with a square. It's still named EFHG, but they're going to change the rules. Points G and H could be below points E and F. Oh gosh, here we go. Now we're talking about below. That means down below that line segment that we started with. So I'm going to use a different color here. I'm not sure what to use that we haven't. So I can safely put light blue on here again. And remember, we do know points E and F. That was our start of the square. So I'm just going to use light blue right underneath it so you can see. This is an edge we're reusing. But this time I want G and H to be below, not above, below. So remember our rules for the square. All segments have to be the same length. All edges are congruent. So if this is 4 units long like it was before, I need to count below it 4 units, or down from there 4 units. 1, 2, 3, 4. I can put a point. I can do the same thing on this other side. I can start at point F and move down 1, 2, 3, 4 units and put a point. If I were to close this figure in, connecting all of the vertices, or all the points I have, do I end up with a square? I certainly do. Now we do have to be careful about how we name this. So take a look. We go back to the name. E is connected to F. Perfect. F is connected to H. So F has to go to H. And next H connects to G. H to G. And then I close it in. G would go back to the beginning. G connects to E. It works. So let's just give the coordinates for these 2 points. Starting at the origin, point G, I have to move backwards 2, so that's a -2. And next I need to move down 3. -2, -3. Point H is located over here, so I need to start here at the origin, and instead of moving to the left, I move to the right, which is a +2. And next I move down how many? 3. So +2, -3. You should be noticing kind of a pattern with this. So you notice that the first number values, the X values stayed the same, and the second number value, the Y values, oops, I was going to try to compare that differently. Let's try that again. I'm looking at G and H from part A. It looks like, actually the second number value, the 5 stays the same. That's the Y value. So -2 and +2 end up being opposites, don't they? Take a look at G and H here. The -3 stays the same. And the beginning coordinate was -2, it became positive. So those, again, the X values become an opposite. All right. Feeling that this is a challenging worksheet. I'm kind of enjoying it. I like a challenge when it comes to math, so don't quit on me. In fact, if this is getting to be tough and you need a little break, step aside, take a break, go read a couple pages in your book for your L&L assignment, and then come back so we can pick up where we left off. Taking a look at number 9, triangle ABC is plotted on a coordinate plane. The coordinates of point A are -2, +2. The coordinates of point B are +6, +2. And the coordinates of point C are 6, 5. Whoa, lots of information. Is this a rectangle like the first problem? No. Is it a square like the second problem? No. It says I have a triangle this time, and it has a special name. I'm just going to sketch myself a little triangle. It's kind of a reminder. That's what I'm going to work on right now, making a triangle. And not all triangles look like that, but that's just my quick sketch. It gives me a reminder, a visual. The coordinates of point A and point B are given, so I can go ahead and, oh, actually all points are given, aren't they? It says point A is located here, point B is located here, and point C is located here. Notice I used some coding to kind of keep track, even though I use the same color. Maybe we can put those on the coordinate plane kind of quickly. Of course, we need a y-axis, because after every great X comes a y. You could number these off if you'd like, but counting our units seems to be working okay. Starting here at the origin, we're going to look for the first point, point A, which says it's located at -2, +2. negative 2 to the left, positive 2 up. We're going up on the elevator. This is point A. Check. Next we're going to look for point B. So starting here at the origin, I need to move 6 which way? To the right. And next I need to move 2 which way? Up. This is point B. Let's see, I want to double check that. 2, 4, 6, positive 2. Yep, okay. And next we're looking for coordinates of point C. So 6, 5. So I'm going to start here at the origin and 6 which way? You would say to the right, and next down 5. And you might say, Mrs. Schumann, this is terrible. Well, it's not terrible, but it definitely is challenging. We might have to sketch something in. When I move 6 to the right and 5 down, it goes off the charts. So I might have to extend this corner a little bit, which you can do. And I'll just sketch it the best I can. Try to make those squares about the same size, the grid about the same size. Not perfect for sure, but I think it will work. So let's try that again. I'm moving 6 to the right, and I'm moving 5. Oh, even more interesting. I misread it. I need to move 5 up, don't I? That's a positive 5. Well, I sure don't want to stop my video now because I don't know how many minutes we are in. I don't want to have to start over, and I don't know how to edit. So we're gonna try that differently. Move 6 to the right and 5 up. 1, 2, 3, 4, 5. Ooh, we just barely made it on the coordinate plane. We'll call that point C. Now remember, this triangle has a special name. It's called A, B, and C for a reason. That means I connect them in that order. A connects to B. B connects to C. And this doesn't look like a triangle unless you take the last point and the beginning point or vertices. I now have a triangle, ABC. It says, what type of triangle is ABC? Well, you can look in your notes, you can look in your planner, you can look on page R10 of your planner, and you would see that this is a special triangle. In fact, it looks like a little tiny square, or even a little bigger square if it's right in the corner. Well, when that happens, it has a special name. That 90-degree angle indicates that this is called a right triangle. Oops, and that's what they wanted me to put on this line. Right triangle. Part A. Part B, figure ABCD is a rectangle. Plot point D on the coordinate plane and give its coordinates. Are you kidding me? We have to reuse this again? Looks like it. And if you remember, triangles are half of a rectangle. So if I were to sketch a rectangle for you right now and chop it in half, you can see that this triangle sitting right down here kind of resembles the triangle I have sitting here, doesn't it? I need to figure out this missing point. So to do that, I need to think about rectangles and what I know about them. We know that their opposite sides are parallel. We know that opposite sides are congruent. We know that they have 4 sides. They're considered quadrilaterals. We also know that their angles should be 90 degrees. So I'm thinking some of those hints might be helpful right now. Like knowing the length of the bottom, that could give me a clue to how long the top should be. So let's count units on the bottom. This line segment AB is 1, 2, 3, 4, 5, 6, 7, 8 units long. If that's true, line segment CD, wherever D lands, should also be 8 units long. So why don't we start here at C and count backwards 8 units. 1, 2, 3, 4, 5, 6, plus 2 more. This is 8 units long. I could call this point D. Let's see what happens when I connect this. Does it work? I'll try to keep my green lines there so that we can still see them for the triangle work we did on part A. But I'll try to put this purple outline on the side of it. Did it make a rectangle? It did. Part B says, give the location of its coordinates. So point D is located at. Let's go ahead and figure out where would you have to go to get to point D. We'd start here at the origin. We would move which way? Left. So that's a negative jump. -2 units to the left. -1, -2. Next I need to move up. So that's a positive movement. I'm moving up 1, 2, 3, 4, 5 units. -2, +5 looks like an answer for part B. Point D is located at -2, +5. This was kind of unnecessary, wasn't it? Thought we were getting into negatives there. All right. Let's peek ahead and see if the next section looks similar. Whoa, this is an interesting shape. Here they give me a diagram and they call it a figure, but it has an awful lot of vertices, has an awful lot of turns. Interesting. It says, in the diagram, figure PQRSTU represents a field. Oh, that makes sense to me. I've been driving down the road before, making a connection. I've seen fields that aren't perfectly square, they aren't perfectly rectangular, and very seldom are they triangular, because those are a little bit harder, I bet, for the farmer to work with. So it says the side length of each grid square is 5 feet. Use the diagram to answer questions 10 to 13. Well, this is really important to me. Something from that reading really stood out. This shape is already drawn in for me. There's an order to it, and I'm hoping they connected it that way. P to Q, Q to R, R to S, S to T. Yep, it seems to work. But there's something important that I read here. It talks about scale. The scale. Each square, each grid square is 5 feet. Notice that each grid equals 5 feet. It's kind of like a scale factor, like you've been talking about a bit in your social studies or INS right now. I also noticed on our axes that they counted by 5s, 5, 10, 15, 20, 25, 30, or backwards, -5, -10, -15, -20. Interesting. All right, it says give the coordinates of these points. So I want to find point P, Q, R, S, T, and U. And I gave you a place to record those here. So if you don't have this on your paper, it might be worth your time to pause the video and just jot that down. We're actually looking for 6 answers because there are 1, 2, 3, 4, 5, 6 different vertices, or 6 different points shown on this grid. All right, point P. We'll do a couple together. Starting here at 0, I need to move back. Point P is located over here. Pay attention to where we stop. We stop at -20. So I didn't actually count 1, 2, 3, 4. I wouldn't want to do that. I could count backwards by 5s, 5, 10, 15, 20, and I know it's negative because I'm moving behind 0. So -20 has to happen first. And next, notice that we move up. Please don't fall into the trap, count 1, 2. It is 2 units, but it's 2 units of 5. Well, 2 units of 5 is 10. Oh, that's perfect. That's what it says on the coordinate plane here. 10 is located here, +10. Let's go ahead and take a look at point Q. Point Q, starting here at the origin where the X and the Y intersect. I'm going to move 1 unit to the right, but those units are counting by 5s. So I'm going to have to record 1 unit of 5, which is the same as 5. After I move here, I need to move up. So don't fall for the trap. Don't say that it's 2 units. Yes, it is, but it's 2 units of 5. So I need to think 2 times 5 gets me 10. And even using your y-axis, that 10 is labeled for us. Point Q, all set. We'll do one more together and then I'll let you work on the others on your own. Point R. I want to think about where point R is located. So starting here at the origin, I have to move to the right or to the left? To the right. And I stop here at the +5. Next I need to drop down and I need to land at the -15. I hope you can see the negatives in front of these numbers. If not, you might want to sketch them in. So 5 to the right, -15 down. 5, -15. There are 3 more points that you're going to be able to help me with. So we took care of P, Q, and R. I'm going to kind of code these for you. We still have to find point S, point T, and point U. And the trick to this one is that we're counting again by 5s. So that's a little bit different than what we've been used to. All right. I'm a little concerned that when I scroll this, I'm going to lose some things, but we're going to try it and hope it doesn't go too poorly. There's another question down here, number 11. I might have to shrink this down so you can see it all. It says, James and Rita build a picket fence around the field. They leave a 5-foot opening for the gate. What is the total length of the fence? Remember your labels. James and Rita build a picket fence around the field. They leave a 5-foot opening for the gate. What is the total length of the fence? Oh, the distance around the field. It says around the field. That's a lot like what we talked about earlier. Perimeter. When I'm finding perimeter, I want to think about total distance around, don't I? So I'm going to add up all the different sides that I have to work with. I do want to be careful. There's something tricky happening here where there's a 5-foot opening. I don't want to close the whole thing in because probably the farmer can't get in, my dog can't get out. That would be a problem. So I want to go ahead and figure out a total perimeter, but when I'm done, I might have to do something about that 5-foot opening. So let's go ahead and maybe we'll just label our edges. What if I started here on the right, just because I feel like it, and I looked at line segment ST. I noticed that it's 2 units of 5, or I could say 5, 10. I'm going to label this edge with 10 units. What if I decided to move into this little inset here, and I move from S to R, or we'd probably say line segment RS. I could count 5, 10, 15, 20. That's 20 units. What if I moved here from R to, I can't really see the letter up there, I'll be honest with you. Maybe Q? Let's go ahead and draw in this line segment. This length would be 5, 10, 15, 20, 25. Notice I have to count by 5s to do this well or to get some accurate answers. I want to go ahead and move along the top of the field. So counting by 5s again, 5, 10, 15, 20, 25. That edge is 25 units. And because I want this fence to go all the way around, I also have to figure out these next 2 lengths, don't I? So counting here by 5s, 5, 10, 15, 20, 25, 30, 35 on this side. And what about the bottom? We could go ahead and close this whole field in. If I knew the length here, I'd know how much fencing to get. 5, 10, 15, 20, 25, 30, 35, 40, 45. Now, I don't really want to order different sections of fence. I'd really like if they could deliver all the fencing at the same time. So James and Rita really want a total of all of those numbers, don't they? So off to the side, I might show some work. I might take all of those measurements and put them in order. I had 45. I had 35. I had 25. I had another length of 25. I had another side on the field that was 20 feet long. I had another side of the field which is 10 feet long. And that takes me all the way around the field. To find a total, I really want to add those up. I see some number bonds that might help me out a little bit, so maybe I'll combine some things. I really like these 25s. I know 25 and 25 gets me 50. And I know 20 and 10 gets me 30. And these are a little trickier to look at, but I could try a number bond. 40 plus 30 gets me 70, and 5 and 5 gets me 10 more. 70 plus 10 gets me 80. I could go ahead and add these up now. I made it a little bit simpler to look at perhaps. 0 plus 0 plus 0, and using our algorithm here, will get us 0 in the ones place. 3 plus 5 is 8, and 8 plus 8 is 16. I'm going to get 160 feet, it looks like. Now there's a small problem. If you close this whole thing in, you'll never be able to get in the fence again. You'll never be able to get out again. Well, we can hope that maybe there's an opening somehow. In fact, it says here that we want to make sure we have a 5-foot opening. Well, if I'm not going to fence the whole thing in, I want to fence in everything but the 5-foot opening. What would I do with this 160 feet total? Instead of closing the whole thing in, we could put a little gate here, or maybe I'd think about putting the gate here, or maybe I'd rather if it was smack dab in the middle or something. But regardless, I'm going to have to take away 5 feet of that fence to make sure I have a gate. So we're going to start with 160 and we're going to subtract 5 from it. Whatever we have left is going to be the total length of the fence I want to order or install. Now I noticed something. There's a little bit of regrouping here, and for some of you that's no big deal. I also could think of it this way. I know that I could count backwards on a number line, and I know when I count by 5s, I get 5s and 0s. So if I took 5 away from this, moving backwards 5, well, let's try it this way. Moving backwards on my number line from 160, I could move backwards 10, and I'd get 150, but that's too much. I want to move half of that. So another way of thinking of that is to know I'd get 155. Or again, regrouping and subtracting would be fun. I get 155, and I sure hope they were measuring in feet. It's way up there at the top. I hope I'm right. I'm going to write feet of fencing. It'd be even more awesome if you wrote James and Rita will build their picket fence with 155 feet of fence. That'd be even better. Let's see if we can take a look at number 12. And before I do that, I really want to make sure they're measuring in feet. I just can't see that up there. Yep, 1 square is equal to 5 feet. All right, number 12. Oh, they tell us where to find the gate. I'm going to have to make this smaller so we can see our coordinate plane. Instead of us telling them how much fencing they need, they're going to ask a follow-up question. They say the gate, line segment VW, lies on RS. Oh, take a look. VW is a line segment. Line segment VW is sitting right here. That's the gate. And it does lay on line segment RS. Here's line segment RS. It's definitely on there. And it is 10 feet from the point S. 10 feet from point S. Yep, it is. 5, 10. I can see that. There's 10 little feet right there. Give the coordinates of point V and W. Oh, they made that way more complex than it had to be. They could have just said, give me the coordinates for point V. Give me the coordinates for point W. So let's go ahead and do that. You're going to start here at the origin where the X and the Y intersect. And you're going to move to the right, but be careful, you're counting by 5s. And next you're going to move down, and be careful, you're moving down, so that's going to be a negative value. With point W, you're going to do something similar. You're going to start here at the origin, you're going to move to the right 3 hops, but it's 3 hops of 5, so be careful. And next you're going to move down 3 hops, or 3 hops of 5, so be careful, that's also going to be a negative value, isn't it? Those negatives are kind of hiding on this one, so make sure you see them there. All right. The last thing it says, find the area of the field. Are you kidding me? The area of the field, we've been talking about perimeter, 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 but now the farmer wants to know what kind of area he has. What that means is how much space is inside. Some of you would remember that's how many square units. So I could actually count 1, 2, 3, 4, 5. Oh my gosh, this is taking forever. 6, 7, 8, 9, 10. Oh my gosh, this is not much fun. There's probably another way to do it. So if you take a look at our field, I noticed something. It kind of looks like 2 rectangles that have been glued together. In fact, we sometimes call that a composite figure. This composite figure can be made up of 2 or more common figures, 2 or more polygons you've seen before. What if I karate chop this right about here? I don't think the farmer would mind for a quick minute, because what I could do is I could find the area of this rectangle and the area of this rectangle, and I'd be able to add them together to find a total area. So again, you could go back to counting your squares, 1, 2, 3, 4. That would take a really long time. So I could do this instead. I could remember, and hopefully it's already labeled for you. Mine has been erased long ago. I could remember how long each edge is and then use that in an area formula. An area of a rectangle can be found with base times height. And I know in the elementary, oftentimes you say length times width. And you might say, Mrs. Schumann, why did you make that L so fancy? Are you trying to be cute? Not at all. I don't want that L to look like the number 1. I don't want it to be confusing. So I do try to use cursive or Danielian, fancy kind of font, just so that you know it means length times width, not 1 times W or 1 times width. Let me go ahead and try to at least get the numbers set back up here with you. So let's talk about this edge over here. 5, 10, 15, 20, 25. Did you remember to count by 5s? And on this other edge, we could count 5, 10, 15, 20, 25, 30, 35. 35 for that upright or that vertical line segment. I want to use those numbers, base times height or length times width, to find the area inside here. So off to the side, you might have to figure out what 25 times 35 gets us. Or maybe you're thinking to yourself, hey, I know what 25 times 30 is. I could take maybe that times 25 times 5 more and add them together. Or you could just try the standard algorithm. Now that's only this part of the field, isn't it? We still have another portion right over here. So I need to know the length of this rectangle and also its height. So the base is 5, 10, 15, 20, 20 units long. And the height here would be 5, 10 units long. In a minute, I'm going to have to multiply those to find the area of this tiny portion of the field. When I'm all done, I'm going to take those and I'm going to add them together. So I'm just going to record for you over here 20 times 10. And after I find those, I have to total them up. And I want to make sure that you label this when you're done. So we just took feet times feet. a base times height, feet times feet, I'm going to get a final answer that's in feet squared. So I'm going to let you finish up the math that's up there. This is a multi-digit multiplication, which I know can give us some trouble. So I want you to do the best you can with it. And if you have questions, be sure to bring them to class next time I see you. I'm thinking this is the end of lesson 9.2, but I want to double check for you. It turns out it is not. So with that, I'm going to pause my video for a quick minute and we'll come right back. Okay, the last page of our assignment here is page 4 of lesson 9.2, length of line segments. And it says, in the diagram, figure ABC represents a playground. The side length of each grid square is 4 yards. So instead of counting by fives like on the last problem, today we're counting each grid square as 4 yards. That's the scale they're using. And if you take a look, they've done a really nice job of labeling each of those lines for you. Whether it's your positives or your negatives away from 0 on the x-axis, or your positives, counting by 4s, away from 0 on the y-axis, or your negatives moving down here. Make sure you can see those negatives in front of those multiples of 4. All right. So it says, give the coordinates of points A, B, and C. I feel like we should already be really good at this. The only trick is you want to make sure you're not counting by 1s, you're counting by 4s. So I'll try point A with you, and I'll set up kind of my organization so that I remember to answer all 3 points. Let's go ahead and start at the origin. So right here at 0, 0. Which way would I move for point A, which is located here in the second quadrant? I would move backwards 4, 8, 12, 16, 20. But that's not a positive 20. I said backwards, so that's a negative 20 that I moved to. Next, I need to move up, and I need you to be careful. You could count 1, 2, 3, 4, 5 for sure, but that's 5 groups of 4. We're counting by 4s. So 4, 8, 12, 16, 20. That's a positive 20 moving up. I need you to try the same thing with points B and point C. But again, remember we're counting by 4s. Number 15. There is a square sandbox D, E, F, G. Oh, some important hints here for me. They say that it's square, and it is D, E, F, G in the playground. Line segment DE is 20 yards from point A and 8 yards in length. EF is also 8 yards in length and is parallel to AC, or line segment AC. Plot and label points D, E, F, and G on the coordinate plane. Holy words, Batman is all I can think. We need to get a sandbox, and it's probably in the playground. It does say it's in the playground. So it says line segment DE is 20 yards from point A. So point A is here. And if I move to the left, I won't be in the playground. So I want to make sure I'm moving into the playground, this direction. And notice it says I want to move 20 yards from point A. So to do that, I'm going to start here at point A, and I'm going to move in 20 yards. We're counting by what number again? 4s. So we'll count 4, 8, 12, 16, 20. So it's 20 yards away. And it also says it's 8 yards in length. So I need to make sure that I'm starting my sandbox right about here. And I'm going to make this line segment DE. It's going to be 8 yards in length. So if I were to call this point D, E would be below it, right? And it would be 8 yards in length. So I'm going to go down 4, 8. 2 units of 4, right about there, would get me point E. There's line segment DE. Took care of the 8 yards in length. And it says line segment EF is also 8 yards in length, and it's parallel to AC. Okay, so it says line segment EF is also 8 yards in length. It better be, because this thing is a square, right? So I can picture a square. All 4 sides should be congruent. And it says it is parallel to AC. So if AC, line segment AC is over here, I want to run a parallel line to AC. I guess my choices would be maybe over here or over this direction. Let's see what else it tells me. Plot and label points D, E, F, and G. Well, I hope I'm not leading us astray is all I can think. I feel like I might have missed something here. So I know this. I want all sides to be the same length. So if this is a side of 8, this is a side of 8. And all sides should be congruent in my square. So let's move this direction, and let's go ahead and move 8 units this way to the right. And I better have the same number of units going the other direction, 4, 8. It works. And 4, 8 this direction. Now I want to make sure that my points kind of line up. So here it says I have line segment DE. D is connected to E. E should connect to F, so this would be point F on the corner. And F connects to G, F to G. And then G should connect back to the beginning. So G could go back to point D. It looks to me like this is going to work. I want to just reread this one more time for my own thinking. It says, there is a square sandbox DEFG in the playground. DE is 20 yards from point A and 8 yards in length. Well, all I can think of is I could have maybe put F and G over here. I wonder if that would have worked. I would have had D, E, F, and G. Still would have made a square. So I'm not sure that that's a problem. And I think it could have been possible. Okay, it says plot and label points D, E, F, and G on the coordinate plane. I've done that. I want to go ahead and read on to number 16. It says if BC is approximately 49 yards. I should have read that maybe line segment. If line segment BC is approximately 49 yards, so going from here to here, 49 yards, what is the perimeter of the playground? Oh, I know why they didn't give that, or why they had to give this to me. They had to give me this length of 49, and they were measuring in yards, because it's actually a hypotenuse of the triangle. It's hard to just measure a straight number of units because it's a diagonal. So let's handle that differently. Let's go ahead and label the 49 units that they tell me it's going to be, 49 yards from point B to point C, and let's also figure out the other edges. So we have to remember to count by 4s here. So I could count 4, 8, 12, 16, 20, 24, 28. 28 units or yards on the left. I also have to figure out this top edge of my playground. So I could go ahead and count 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Another way to check that would be talking about absolute value. The absolute value to get to negative 20 would be 20 units. The absolute value to get to positive 20 is 20 units. 20 and 20 gets me that total of 40 yards for the length. So now they tell me to find the perimeter, and perimeter again means what? The sum of all sides. So let's try that. I'm going to stack these up. I'm going to add them up. I have 49 plus 40 plus 28. And one of those I didn't want to measure myself. They told me it's approximately 49, so I'm going to use the value that they gave me. We'll just try the algorithm for this. I have 9 ones plus 8 ones gets me 17 ones. I'll regroup the 1 to the tens place. 4 tens plus 4 tens plus 2 tens is 10 tens, plus 1 more makes 11 tens. Looks like I'm getting a total perimeter of 117. 117 what? What am I measuring in? They actually told me to use the unit yards. So that'll be my final answer. Number 17 is almost cut off here, so I'm going to clear what we've got going. I'm going to try to slide us up a little bit just to finish this last problem with you. And still keep our coordinate plane there. Number 17. Tanya starts at point E and rides her scooter around the perimeter of the playground toward point B. Oh, this could be a problem because I just got rid of my sandbox, didn't I? So I'm going to think back. Whoops, I just changed everything crazy colors, didn't I? My sandbox is sitting somewhere here. I remember it being a square. I don't exactly remember the name of the vertices, so DE was 20 yards away. So this might have been DE, and that was connected to F and G. I feel like we should touch on this so we can see things better. That looks good. Okay. It says Tanya starts at point E and rides her scooter around the perimeter of the playground toward point B. Ooh, this makes me think that my sandbox is not accurately depicted. Big pause in my video. Probably should have put it on pause. I'm really just thinking here. I feel like we still have good answers for a lot of this. Our sandbox is still in the right location, but I feel like the naming of it went wrong. So I am not a robot. I am Mrs. Schumann. And I feel like maybe I should rethink the way that they labeled this. So on the spot here, I need to reconsider this part 15, number 15. If it tells me line segment EF is, let's see, line segment DE is 20 yards from point A. Maybe I need to start with line segment DE here. And the reason why I say that, and am rethinking it right now, I don't really want my Tanya, my bicyclist, to start with her scooter in the middle of my playground and try to figure out her perimeter. It would make better sense to start with her on an edge. So if I were to plot line segment DE here, it's still in the same location as my sandbox was before, but my labeling is a little bit different. Now if I were to connect D to E, E to F, and point F to point G, my labeling would be a little bit different than it was before. Let's see if this will help us out with this problem for number 17. If Tanya starts at point E and rides her scooter around the perimeter of the playground toward point B. Oh, so she's going to go around and she's starting at point E. So starting here, she could head probably this direction because it says she's going to go around the perimeter. She's going to go this way and she's going to come back towards point B. It says if she travels at 5 yards per second, about how many seconds will it take her to get to point D? So 5 yards per second, how many seconds will it take her to get to point D? She's also going to have to come back and she's going to end up at point D, the way I made my sandbox this time. All right, so food for thought. First, I need to figure out how far she's traveling. So she's starting at E and she's coming all the way back to point D. So let's go ahead and count by our units of 4. I could start here at E. I could count 4, 8, 12, 16, 20, 24, 28. She's going to move 28 units this way. Next she's going to move by 4s going this direction. 4, 8, 12, 16, 20, 24, 28. 28 units going this direction. Next, she's going to head this direction, and we said that was about 49 units. It was given to us earlier, so I'll just record the 49 yards that we were given earlier. And next she has to come back to point D. So she's going to move 4, 8, 12, 16, 20 more units, or 20 more yards in this case. Well, we probably should figure out a total distance, how far she's gone. We already added up a lot of this earlier. The only thing that's really happening is I see a little bit of an overlap here. So it's almost like we would add on 8 extra yards. But let's go ahead, we'll total it up in case you are doubting where we are right now. I have 49 plus 28 plus 28 plus 20. And I want to just double check this. 4, 8, 12, 16, 20, 24, 28, that's good. 4, 8, 12, 16, 20, 24, 28, that's fine. This 49 yards was given to us. We really want to figure that one out on our own. And next I'll count 4, 8, 12, 16, 20 more. All right, let's try some quick number bonds here. Is there something that will work nicely? 28 and 28 you might recognize as 56. If you don't have to do this. 20 plus 49 gets me 69. And I could go ahead and add those together. 9 plus 6 gets me 15. We'll regroup the 1. 6 plus 5 and 1 more makes 12, 125. Looks to me like she's moving 125 yards total. Now that's not quite the question. This is the total number of yards she's moving. And again, if I had more space, it would probably be down here next to number 17, which we're on right now. But it says she's going to travel at 5 yards per second. About how many seconds will it take her to get to point D? She's traveling at 5 yards per second. That means every single time I take 5 yards out of this, it takes a second. So I could repeatedly subtract. I see some of my students like to do that. 125, take away 5, take away 5, take away 5. And every time you take away a 5, that would kind of be the number of seconds we're talking about. But there's probably a faster way. I'm breaking that 125 yards into groups of 5. That's the same as dividing. So I really want to think about how many times 5 goes into this number. 5 does not nicely go into one group of 100. It's hard to split that 100 into 5 groups without making it a fraction or decimal. So I'll put a 0 in my algorithm or in my quotient here. Next, 5 does go into 12. If I have 12 tens, I could put 2 tens in each group. 5 goes into 12 twice, nicely. 2 times 5 is 10, and when I subtract, I'm left with 2 remaining. I have another number to bring down, so I can treat this like 25 ones, and I can break those 25 ones into 5 groups. How many would go in each group? 5 goes into 25 5 times. 5 times 5 is 25, and when I subtract, I'm left with nothing. 25 seems to be my answer. So what did we just find? Let's go back to the question. I didn't highlight much here, did I? I had to go back and replace my sandbox and all of that, so that was kind of a costly mistake. About how many seconds will it take her? Well, I found the total number of yards. I took the yards and I split them into groups of 5, and I found out that it's going to take her about 25 seconds. I asked how many seconds will it take for Tanya to get all the way around and back to point D. There is some serious questioning going on in my mind right now about that sandbox and why I got it wrong in the first place. I think maybe I missed this idea, D, E, E, and F. Maybe this idea earlier, it says line segment E and F had to be parallel to AC. If AC is running vertically, E and F has to run vertically. So maybe this is a better situation to have us in right now. So I think this is a better place for our sandbox. I think we can still agree that it fits here. I think the labeling of it might just be slightly different for number 17. All right. With that, this was a challenge, not only for you, but also for me who hasn't done it in a year. So I hope you learned something new. I hope you tried something different. I hope that finding length on a coordinate plane that goes with our line segments was something that you're able to do. You'll have some similar questions to this in the upcoming test. So if something's not making sense, do come in with some good questions when I see you again.